Close your eyes for a moment and imagine a world painted red. Not a vibrant red like a rose, but an oxidized, rusty shade, like ancient metal exposed to the elements. This is Mars, the red planet, whose name evokes the Roman god of war. But its color doesn't come from battles. It comes from something much more mundane, and, at the same time, poetic. Rust. The Martian surface is covered in iron oxide, the same compound that forms when iron meets oxygen and time. Mars, in a way, is a planet that has rusted over billions of years. If you could land on Mars and observe the passage of time, you would notice something reassuringly familiar. A Martian day, called a sol by scientists, lasts 24 hours and 37 minutes. It's almost identical to our Earth day, only slightly longer. You could easily keep a clock similar to the one you use here. But a Martian year is another story. Mars orbits the Sun at a greater distance than Earth, and its journey around our star takes 687 Earth days, almost twice as long as our year. Martian seasons are long, each lasting for months at a time. And these seasons bring with them something truly spectacular and terrifying. Dust storms. Not small bursts of sand, but colossal storms that can engulf the entire planet. Imagine waking up one Martian morning and looking out the window of your hypothetical base, seeing a wall of dust approaching. A cloud so vast it would darken the sky for weeks or even months. These are the largest dust storms in the solar system, phenomena that can make the sun disappear completely and transform the day into an orange and sinister twilight. The atmosphere surrounding Mars is thin, almost a whisper compared to ours. It's composed primarily of carbon dioxide, 95%, and is so rarefied that you could walk through it with little resistance. It's less than 1% the density of Earth's atmosphere. Breathing in it would be impossible, and without a pressurized suit, your blood would literally begin to boil due to the low pressure. But it wasn't always like this. Billions of years ago, Mars was a very different world. Rivers snaked through valleys, lakes filled craters, and perhaps, just perhaps, oceans covered its northern plains. The evidence is etched in Martian geology. Dry channels clearly carved by flowing water. Mineral deposits that only form when submerged, fossilized river deltas. Mars was once a wet world, a place where water flowed freely under a sky that may have been blue. If you could walk on Mars today, you would feel something strange and liberating. Weightlessness. Martian gravity is only 38% of Earth's. Each step would be a small leap. You could jump 3 times higher than on Earth. A single jump could lift you meters into the air. It would be like having superpowers, albeit in a hostile world. On the horizon, if you were lucky enough to be in the right region, you could see the silhouette of Olympus Mons, the largest known volcano in the solar system. At 26 kilometers high, it is 3 times taller than Everest. But its base is so vast, 600 kilometers in diameter, that if you were on its slopes, you wouldn't be able to see the summit. It would disappear beyond the curvature of the horizon. It is a sleeping giant, inactive for millions of years, but still dominating the Martian landscape. Look at the Martian sky, and you would see 2 small irregular moons, Phobos and Deimos, named after the sons of the god of war, fear and terror. They are not like our moon. They are small, asymmetrical, looking more like cosmic potatoes than spheres. Most scientists believe they are asteroids long ago captured by Mars's gravity. Phobos, the larger of the two, is slowly approaching the planet. In 30 to 50 million years, it will either collide with Mars or fragment, forming a temporary ring around the planet. A spectacle that no human eye will see, but which will inevitably happen. And at the end of the Martian day, you would witness something magical: the sunset. But it wouldn't be the golden and orange sunset we know on Earth. On Mars, the sunset is blue. The fine Martian dust suspended in the atmosphere scatters sunlight in a unique way, creating a twilight in shades of blue around the solar disk as it descends below the horizon. It's one of the most beautiful and alien phenomena we could imagine. Martian temperatures are brutally cold. The average is around 63 degrees Celsius below zero. But near the equator, during the Martian summer at midday, the temperature can reach up to 20 degrees Celsius, almost comfortable if it weren't for the lack of breathable air and the dangerously low atmospheric pressure. At night, however, temperatures plummet again, and the cold returns with a vengeance. The atmospheric pressure on Mars is so low, less than 1% of Earth's, that liquid water cannot exist for long on its surface. It boils immediately or freezes, unable to remain liquid. And yet, NASA has identified minerals such as clays and sulfates that only form in the presence of liquid water. This is further evidence that Mars was once a place where water flowed and accumulated. Deep beneath the Martian surface lies a partially liquid core, much like Earth's. But Mars's core is smaller and far less active, and long ago, Mars had a strong magnetic field generated by this core. But for reasons not yet fully understood, it disappeared. Without this magnetic protection, the solar wind, streams of charged particles emitted by the sun, began to strip away the Martian atmosphere layer by layer over billions of years. This is why Mars today is so cold, so dry, so barren. But all is not lost. There is water ice at the Martian poles, covered by layers of carbon dioxide frozen during the winter. And beneath the surface, in various regions, there is subsurface ice, frozen reservoirs that future explorers may be able to access. And the color of Mars? It's not just a uniform red. Up close, the planet reveals shades of brown, gold, gray, and even black in its volcanic rocks. The surface is a palette of oxidized colors, a world that once lived and now rests in silence. But there is one final mystery that keeps scientists intrigued. Methane has been detected in the Martian atmosphere. Not in large quantities, but it's there, appearing and disappearing seasonally. On Earth, most methane comes from biological processes. Life? On Mars, it could be geological, resulting from chemical reactions in rocks. Or could it be something else? Could there be microbial life hidden beneath the surface, producing small amounts of methane? The question remains unanswered. Breathe slowly. Imagine yourself floating above Mars, looking down at that silent world of rust and memories. The Martian soil hides an invisible danger. Analyses conducted by rovers have revealed the presence of perchlorates, chemical substances highly toxic to humans. This complicates the dreams of future colonists who imagined simply planting seeds in the red soil. Any direct cultivation on the Martian surface will require extensive soil treatment or agriculture in completely controlled environments. Mars does not make it easy for those who wish to call it home, but the planet is constantly being reshaped by subtle forces. The Martian wind, though weak, never rests. It sculpts gigantic dunes that can completely change shape over months. They are ephemeral sand sculptures, always in motion, always transforming. If you were to return to the same spot after a few months, the landscape might look strangely different. And everywhere, buried in the ground, are sedimentary rocks, compacted layers of sediment that can only form in the presence of water. These rocks are like pages from an ancient book, telling stories of tranquil lakes, of rivers that slowly deposited their sediments, of a Mars that was, in many ways, more like Earth than it is today. One of Mars's most impressive features is Valles Marineris, a canyon system so vast it makes the Grand Canyon look like a mere crack. It stretches for over 4,000 kilometers, 10 times the length of the Grand Canyon, and plunges to 7 kilometers deep in some places, 4 times deeper than its terrestrial counterpart. If you were on one edge of this abyss, the other side would disappear beyond the horizon. It's an ancient wound on the surface of Mars, possibly formed when the planet cooled and its crust cracked. Mars has become the most explored planet in the solar system after Earth. Dozens of orbital and surface missions have already been sent, and more are planned. It captures our imagination not only because of its proximity, but because of its tantalizing similarities to Earth, as if it were a dark mirror of what our planet could have become. Mineral analyses reveal traces of volcanic compounds, suggesting that Martian volcanoes have been active not for millions, but for billions of years. Olympus Mons and other volcanic giants have spewed lava for unimaginable geological eras, slowly building their colossal structures. Hidden just beneath the surface dust in some craters lies ice, not just at the far poles, but in mid-latitudes as well, waiting silently. Future explorers may drill a few meters and find frozen water, a vital resource for any human mission. But the danger is constant. The Martian air is so thin that a human being without a spacesuit would die in about 10 seconds. The extremely low pressure would cause the blood to boil, the lungs to collapse, and exposure to the near-total vacuum would be fatal almost instantly. Mars does not forgive mistakes. From time to time, tiny dust tornadoes, affectionately called dust devils, dance across the Martian surface. They are fragile but fascinating whirlwinds to observe, raising columns of sand that twist and turn before disappearing. NASA's rovers have already captured images of these ephemeral phenomena traversing dusty plains. Martian winter is brutal in a way we don't experience on Earth. It gets so cold that part of the atmosphere itself freezes. Carbon dioxide solidifies at the poles, forming glistening layers of dry ice. And when spring arrives, this ice sublimates directly from solid to gas, creating spectacular jets that erupt from the surface. Without a protective magnetic field, Mars is constantly bombarded by cosmic and solar radiation. The surface receives about 50 times more radiation than Earth. Any future human inhabitants will need to live under thick layers of soil or inside structures protected by heavy shielding. Radiation is a silent and invisible killer. Some Martian rocks are so old that they date back to when the first terrestrial continents were forming. They are silent witnesses to billions of years of planetary history, preserved in a world where erosion is slow and gentle compared to Earth. After the large global storms that occasionally engulf Mars, the planet becomes even redder. The ultrafine dust, now redistributed, covers every rock, every valley, every mountain, intensifying that characteristic rusty hue, It's as if the planet is periodically repainting itself. The Curiosity and Perseverance rovers, solitary robotic explorers, have found something revealing: rounded and smoothed pebbles. On Earth, rocks like these are shaped by strong flowing rivers. Finding them on Mars means that, at some point in the distant past, vigorous rivers flowed through those now silent and dry landscapes. The two small moons of Mars have opposite fates. Phobos completes an orbit around the planet in just 7 hours and 39 minutes, so fast that it rises in the west and sets in the east, the opposite of most celestial objects. And it is doomed, constantly approaching Mars. Meanwhile, Deimos does the opposite. It slowly moves away, gaining altitude, eventually escaping into deep space. Calculations based on geological features suggest that Mars likely had enough water to cover its entire surface with an ocean 140 meters deep. Imagine a completely aquatic Mars, a blue world instead of red. This water existed, but it was lost. Some evaporated into space. Some froze permanently beneath the surface. Mars is covered in thousands of craters, marks of impacts that occurred over billions of years. But many of them are gradually erased by dust storms, slowly filled with sediments carried by the wind. It's a very slow but constant process of geological renewal. And on Martian mornings and afternoons, you might see something surprisingly familiar. Small white clouds of water ice crystals floating in the atmosphere. They are faint, ephemeral, but vaguely reminiscent of the clouds we see on Earth. Even in such a different world, there are echoes of home. And here's something extraordinary. Some meteorites found on Earth are actually pieces of Mars. Billions of years ago, asteroids collided with Mars with such force that they launched rocks into space. Some of these rocks, after wandering through the solar system for millions of years, eventually fell to Earth. We can hold Mars in our hands, study it in laboratories, touch a distant world without ever having traveled there. Breathe slowly. Imagine these alien landscapes, these shape-shifting dunes, these canyons that defy the imagination. When the densest dust storms engulf Mars, the world plunges into near total darkness. Sunlight diminishes so much that the rover's solar panels almost cease to function. These small robotic explorers, dependent on solar energy, enter a forced hibernation mode, patiently waiting for the storm to pass and the light to return. The Opportunity rover met this fate tragically. In 2018, a global dust storm engulfed Mars, and Opportunity, which had explored the planet for nearly 15 years, far beyond its planned 90-day mission, was trapped in darkness. NASA tried to re-establish contact for months, sending hopeful commands through the void of space. But Opportunity remained silent. It never woke up again. Its last message, poetically interpreted, was something like, "My battery is low and it's getting dark." It now rests in Perseverance Valley, a silent monument to human exploration. But the valleys that Opportunity and other rovers have explored tell older stories. Some Martian valleys bear an uncanny resemblance to Earth's river formations, winding meanders, depositional deltas, branching channels. They suggest not just ephemeral flows of water, but long-lasting rivers that flowed for thousands, perhaps millions of years. About 3 billion years ago, Mars was much warmer and wetter, a world where the water cycle functioned similarly to Earth's. But present-day Mars is unforgiving to liquid water. The atmospheric pressure is so low that even at temperatures below 0 degrees Celsius, liquid water boils immediately. There is no temperature at which it can remain stable in a liquid state on the surface. It either freezes instantly or evaporates directly, never remaining as the precious liquid we know. And yet, there is evidence that water existed. Some Martian rocks exhibit patterns that resemble mud fractures, that polygonal pattern we see when mud dries and cracks under the sun. It's an unmistakable signature of wet and dry cycles, of puddles that formed and then evaporated repeatedly. The tracks left by the rovers in the Martian dust remain intact for years. On Earth, wind, rain, or simply the passage of animals would quickly erase these marks. On Mars, they persist, clear lines crossing the landscape as if they were made yesterday, even if they are years old. It is a world where the past is easily preserved. And there is something surprisingly poetic about Mars. Singing dunes. In some regions, when grains of sand slide over one another, whether by the action of the wind or by gravity on steep slopes, they produce deep, resonant sounds. These are profound notes that echo through the thin air, an alien music played by the landscapes themselves. In certain Martian locations, deposits of pure silica have been found. On Earth, concentrated silica is usually associated with hot springs, places where hot, mineral-rich water bubbles up from the depths. And hot springs on Earth often harbor microbial life. The presence of silica on Mars raises the tantalizing question: were there Martian hot springs? And if so, did they harbor life? The volcanoes on Mars are so large that they defy comprehension. Their bases extend over areas equivalent to the size of entire countries. Olympus Mons, for example, covers an area similar to that of France. Imagine a volcano so vast that you could walk on its surface for days and still be on the same mountain. In polar regions, ice caps change dramatically with the seasons. In winter, when the intense cold freezes even the carbon dioxide in the atmosphere, the caps grow, expanding to cover vast areas. In summer, they recede, sublimating directly from solid to gas, releasing enormous quantities of CO2 back into the atmosphere. It's a planetary respiratory cycle. Recent evidence suggests that Mars may have had salty underground lakes in the recent past, perhaps even a few million years ago, a blink of an eye in geological terms. Salt water can remain liquid at lower temperatures than pure water, and hidden beneath the surface, protected from low atmospheric pressure, it could have persisted. These underground lakes, if they existed, could have been havens for microbial life. The Martian atmosphere is so thin that it offers little protection against meteorites. Small meteorites that would disintegrate completely in Earth's atmosphere manage to pass through the Martian atmosphere and impact the surface. This is why Mars is so densely cratered. Each small cosmic projectile leaves its mark. Landing on Mars is an immense technical challenge. The low gravity and thin atmosphere mean that parachutes alone are not enough. Probes need to use powerful retro rockets and, in recent missions like Perseverance, a sky crane that suspends the rover by cables as it descends smoothly. It's a precise dance of engineering, where the slightest mistake can be catastrophic. The Martian surface is a mineralogical treasure trove, containing magnetite, hematite, and olivine, minerals that we also find on Earth, but here contextualized in a completely different world. Studying these minerals helps us understand not only Mars, but also the fundamental geological processes that shape rocky planets. Although Mars is cold and distant, sunlight is still intense enough to be dangerous. Ultraviolet radiation, unfiltered by a thick atmosphere or ozone layer, can cause severe burns with prolonged exposure. Any future human explorer will need a protection not only from the cold and lack of air, but also from the seemingly gentle sun shining in a peach-colored sky. On Martian mornings, thin mists form, not of water droplets as on Earth, but of tiny ice particles suspended in the air. They dance in the dim light of dawn before sublimating as the sun rises. The Martian climate is so dry, erosion so slow, that impressions left by ancient water flows remain clear even after billions of years. It's as if the planet has been frozen in time, preserving evidence of its aquatic youth for future explorers to read. The Perseverance rover carries an experiment called MOXIE, a device that extracts carbon dioxide from the Martian atmosphere and converts it into breathable oxygen. It's a crucial test for future manned missions. If we can produce oxygen locally, we won't need to transport it from Earth, making colonization much more feasible. And from time to time, small avalanches occur on Mars, especially near ice cliffs at the poles. When spring arrives and the sun warms these cliffs, chunks of ice break off and fall, creating ephemeral cascades of ice and dust that slide down the slope before settling again in silence. Close your eyes. Imagine yourself walking across the Martian surface, feeling the lightness, seeing the peach-colored sky, hearing the absolute silence broken only by the creaking of your footsteps in the sand. Mars has seasons, just like Earth, but these seasons are longer and more drawn out. Each one lasts almost twice as long as ours because the Martian year is much longer. Imagine a winter that persists for months on end, or a summer that seems to never end. Mars's seasonal rhythm is slower, more deliberate, as if the planet were breathing in slow motion. And Martian temperatures fluctuate dramatically. The thin atmosphere can't retain heat, so the differences between day and night are brutal. In just a few hours, the temperature can drop more than 70 degrees Celsius. You could experience a relatively mild afternoon, and by nightfall, be in a deadly freezer. It's a world of extremes. Although Mars experiences electrical storms, they are pale ghosts compared to our own. The low humidity and thin atmosphere mean that lightning is rare and weak. There are no thunderous roars cutting across the Martian sky, only occasional silent and faint discharges. The planet emits residual heat into space in a peculiar way. The dry, dusty soil acts like a kind of blanket, retaining temperature more slowly than damp or bare rocky surfaces. It's another consequence of Mars's extreme aridity. Even heat moves differently. Martian dust is an insidious adversary. It is so incredibly fine, with particles smaller than grains of talcum powder, that it can penetrate any mechanism, no matter how well sealed. It is a constant problem for the rovers, seeping into joints, covering solar panels, and requiring engineers to design systems that are increasingly resistant to this microscopic invasion. Throughout Mars, there are formations that resemble river deltas, those fan-shaped structures where rivers flow into larger bodies of water, depositing sediment over centuries. Finding them on Mars means that not only was there flowing water, but that this water flowed consistently for long enough to build these complex structures. They were perennial rivers, not just occasional floods. In the distant past, about 3 to 4 billion years ago, Mars likely had a much thicker and warmer atmosphere. Beneath this protective blanket, lakes could have existed for millions of years, their calm waters reflecting a sky that may have been blue, not the peach color we see today. But then something changed. Mars lost its global magnetic field, and without this protective shield, the surface was completely exposed to the solar wind, that constant stream of charged particles emanating from the sun. This wind, over eons, stripped away the Martian atmosphere layer by layer, transforming a potentially habitable world into a frozen wasteland. And there is provocative evidence of something even more dramatic: signs of ancient Martian tsunamis. Peculiar geological deposits suggest that gigantic waves swept the coast of primitive seas, possibly triggered by asteroid impacts. Imagine that. Mars had oceans vast enough for tsunamis to form, colossal waves sweeping across alien seas. Over immense timescales, Mars is gradually moving away from the Sun. It's an incredibly slow process, imperceptible on human timescales, but over millions of years, this will alter its climate in subtle yet significant ways. The Curiosity rover has made an intriguing discovery: seasonal variations in methane in the Martian atmosphere. Levels rise and fall with the seasons, but no one knows definitively why. It could be geological, resulting from chemical reactions in the rocks, or it could be biological. The question remains agonizingly unanswered. The dust covering Mars is so fine that, once suspended in the air by a storm, it can remain floating for weeks before slowly settling back down. It's as if the atmosphere has a memory, keeping the dust suspended long after the winds have died down. Our fascination with Mars is nothing new. In the 19th century, Giovanni Schiaparelli created the first detailed maps of the planet using telescopic observations. He saw what he called canali, channels, which were erroneously translated as artificial canals, sparking decades of speculation about Martian civilizations. We now know they were optical illusions and natural formations, but the imagination had been captured. More than 50 missions have been launched to Mars since the beginning of the space age, but it is an unforgiving fate. Almost half of these missions have failed. Orbiters that never reached their orbit, landers that crashed on the surface, rovers that never woke up. Mars has a reputation as a spacecraft devourer, a testament to the extreme difficulty of reaching and landing on that distant world. The color of the Martian sky is not constant. Depending on how much dust is suspended in the air, it can vary between pale yellow, deep orange, and earthy brown. During dust storms, the sky darkens to an apocalyptic shade of deep red. Some valleys on Mars are older than any river on Earth. They formed when Earth was still in its turbulent infancy and persist to this day, preserved by slow Martian erosion. They are relics of a time when both planets were young. The Mars Reconnaissance Orbiter, orbiting Mars, has a camera so powerful it can take detailed enough photos to see individual rovers on the surface. Tiny dots moving slowly, leaving sharp trails behind them. It's like having a spy satellite observing explorers on an alien world. Martian craters are open books of geological history. Some have exposed layers on their walls, like slices of geological cake, that reveal millions or even billions of years of deposition, erosion, and transformation. Each layer is a page, telling stories from different eras in Martian history. Mars didn't just have giant, slowly effervescent shield volcanoes like Olympus Mons. It also experienced explosive volcanism, violent eruptions that hurled ash and rocks into the sky, creating deposits of volcanic material scattered across vast areas. Scattered across the surface are formations that geologists call rocky islands, isolated structures rising from the surrounding plain. They suggest ancient catastrophic floods, so powerful that they sculpted the terrain into dramatic shapes, leaving these islands as solitary witnesses to long-vanished deluge. Let your mind wander over these ancient landscapes. Imagine oceans that no longer exist, rivers that stopped flowing billions of years ago, skies that have changed color. Relax deeply. We are nearing the end of our Martian journey. Water on Mars behaves in a peculiar way. When Martian ice thaws, it rarely turns into liquid as we might expect. Instead, due to the extremely low atmospheric pressure, the water passes directly from a solid to a gaseous state, a process called sublimation. It's as if the ice simply evaporates, completely skipping the liquid phase. Imagine walking on Mars at dawn, watching the previous night's ice disappear into mist without ever having been flowing water. But Mars holds unmistakable evidence of a wet past. Extensive deposits of gypsum have been found, a mineral that on our planet forms almost exclusively in environments with abundant water. The presence of gypsum is like finding a fingerprint left by ancient water, a chemical mark that tells us, yes, this place was once wet. Mars' reduced gravity, only 38% of Earth's, creates fascinating architectural possibilities. Structures can be built much taller without risk of collapse. Martian skyscrapers could reach unimaginable heights on Earth. However, the extremely thin atmosphere makes everything vulnerable to cosmic and solar radiation. What we gain in structural possibilities, we lose in natural protection. Any Martian colony would need to resolve this fundamental dilemma. One of the most surreal sights Mars offers is the blue sunset. While on Earth the sky is painted orange and red at dusk, on Mars the opposite happens. The sun sets in shades of blue, surrounded by a bluish halo against an ochre sky. This occurs because fine dust particles in the atmosphere scatter light differently than air molecules do on Earth. It's a phenomenon that challenges our sensory experience, a sunset that seems to belong to a dream. In various regions of Mars, rovers have found small spheres of hematite that scientists have affectionately nicknamed blueberries. These tiny mineral balls, usually only a few millimeters in diameter, formed in the presence of water. They are like geological time capsules, preserving evidence of ancient environments where liquid water flowed freely. Beneath the dusty surface lie intriguing signs of ancient subterranean aquifers. Networks of channels and reservoirs that may have existed billions of years ago, perhaps harboring microbial life protected from surface radiation. The idea that Martian life may have existed not on the surface, but hidden in subterranean aquifers, remains one of the most fascinating hypotheses in astrobiology. The InSight probe has brought an important revelation. Mars is geologically active. The planet experiences earthquakes, aptly called Marsquakes. These tremors are generally weaker than those on Earth because Mars does not have active tectonic plates like Earth. But they occur regularly, caused by the gradual cooling of the planet's interior and by meteorite impacts. Each detected tremor helps scientists map the internal structure of Mars, as if they were performing an ultrasound of the entire planet. The Martian atmosphere is so thin that flying there represents an extraordinary challenge. The air density is less than 1% of Earth's. For a helicopter to function in these conditions, it would need extremely lightweight blades spinning at incredible speeds. This challenge was overcome by ingenuity, a small helicopter that became the first human-built object to achieve controlled and powered flight on another planet. In 2021, it lifted off from the Martian surface, marking a historic moment equivalent to the Wright brothers' flight, but on another world. The lighting on Mars is subtly different from Earth. Shadows are darker and more defined because there's much less light scattering in the thin atmosphere. On Earth, even shaded areas are indirectly illuminated by light scattered by the air. On Mars, shadows are almost black, creating dramatic contrasts that give the planet a cinematic, almost artificial appearance. During the Martian summer, when temperatures rise slightly above freezing in some regions, something peculiar happens. Some cliffs have dark trails formed by materials sliding down the slope. Scientists debate whether these seasonal flows involve salt water or are simply avalanches of dust and sand. Regardless of the final explanation, they are reminders that Mars is still an active and dynamic planet. Valles Marineris, that gigantic canyon system we've already mentioned, is on a scale that defies comprehension. If it were located on Earth, it would stretch across the entire United States from coast to coast. Imagine a canyon so vast that it would begin in the Atlantic Ocean and end in the Pacific. That's the magnitude of Valles Marineris. Climate studies suggest that Mars goes through cycles of warming and cooling every few million years, caused by changes in the tilt of its axis. These cycles can redistribute ice between the poles and mid-latitudes, temporarily altering conditions on the surface. Understanding these cycles is crucial for predicting the planet's future and for planning long-term missions. Mineralogical analysis of Martian rocks has revealed the presence of jarosite and goethite, minerals that typically form in aqueous and sometimes acidic environments. Their presence tells stories of ancient lakes and rivers, of complex chemistry occurring in waters that no longer exist. Rocks collected and analyzed by rovers show evidence of repeated cycles. Lakes that filled and dried up, filled again and dried up again, over millions of years. This pattern suggests a planet that experienced periods of greater humidity interspersed with dry periods, perhaps linked to those long-term climate cycles. Martian dust has interesting electrical properties. It is electrostatically active, clinging tenaciously to any surface it touches. Solar panels become covered, spacesuits become impregnated with it, and equipment needs constant cleaning. This sticky dust will be a constant challenge for future colonists. Martian air, though thin and unbreathable, contains valuable elements. There are traces of nitrogen and argon, both important for potential agricultural systems. With appropriate technology, the Martian atmosphere could provide essential resources to sustain human life. We cannot breathe it, but we can process and utilize it. The MAVEN mission brought a melancholy revelation about the fate of Mars. It showed that much of the planet's atmosphere was literally stripped away by the solar wind over billions of years. Without a strong global magnetic field to protect it, the Martian atmosphere was gradually eroded by the constant flow of charged particles from the Sun. This is why Mars, which possibly had a dense, life-friendly atmosphere in the distant past, is now a cold, dry desert. And the process continues. Even now, at this very moment, Mars is losing small amounts of its atmosphere to space every day. It's a slow and inexorable bleeding. The planet breathes into the void, exhaling molecules of its already scarce atmosphere, becoming a little thinner, a little colder, a little more inhospitable with each passing day. But there is hope in this melancholy, because now we understand what happened. And with understanding comes the possibility of change. Future technologies may one day allow humanity to give back to Mars some of what it has lost. Perhaps we can artificially thicken its atmosphere, recreate a controlled greenhouse effect, protect the planet from future atmospheric losses. Perhaps Mars, which was blue and wet billions of years ago, can become so again, not through natural processes, but through human ingenuity. As you close your eyes tonight, think of Mars silently spinning in the dark, its deep canyons filled with black shadows, its polar ice caps gleaming in the distant sunlight, its sand dunes sculpted by winds no one hears. Think of the solitary rovers traversing its rocky plains, the helicopters buzzing in its thin atmosphere, the instruments recording every tremor, every change in temperature, every gust of wind. Mars awaits us, not in haste, not with impatience, but with the infinite patience of a world that has existed for billions of years and will exist for billions more. It is there, always visible in the night sky as a bright red dot, a promise and a challenge, a place we know better and better, but which still holds countless secrets. And who knows, perhaps in a few decades there will be human beings sleeping on Mars, looking through the windows of their habitats at that same sky you see now, but from a different angle, thinking of Earth as a distant blue dot, dreaming of the day when Mars will have clouds of water again, when it will have rivers running through its ancient valleys, when life will return to a world that once sheltered it. Sleep well, knowing that we live in an extraordinary era, when humanity is only beginning to take its first timid steps towards other worlds. Tonight's dreams may become tomorrow's reality. Good evening, explorer of worlds. May your dreams be as vast as Valles Marineris, as colorful as a blue Martian sunset, and as full of possibilities as the future that awaits humanity among the stars.